All right, so let's do these programming exercises. Chapter 3, Computing with Numbers, page 76. Write a program to calculate the volume and surface area of a sphere from its radius given as input. Here are some formulas that might be useful. And then they give us the formula for the volume and the area of a sphere. So let's check this out. Let's go to new file. I was doing the Leibniz program before. I don't know if you guys got a sneak peek at that, but kind of fun. Like knowing where to put the variables to put them inside the loop, or usually want to initialize them outside the loop and then obviously let them run. But these are just simple mistakes that just this early practice helps you out with. Really burning it in your brain as far as examples. So let's just write v equals 4/3 times pi times r cubed. And then this program computes the volume and area of a sphere given the user input of r radius. Formula for volume, for sphere volume, and then formula for sphere area, surface area. So since it's a three-dimensional object, we want to make it really clear. So it's surface area. I just put it up here so I don't have to look for it if I mess up. All right, just so you have it in the program. Plus, I'm pretty sure teachers tend to like that. But just regardless, it's good practice even if you're in industry. I'm sure this stuff is helpful. I mean, if you go on to another company and I don't have a lot of experience with this, but I've definitely been sniffing around and asking questions and whatnot. And yeah, you want to have like maintainable code, so you got to have it's recommend you have good comments. All right, so let's do sphere. Oh, you already have one. Use some other program. Okay, so sphere.py. Okay, so this, let's just go way down here for user input. So it's going to be volume equals, it's going to be, actually we're not going to need to create the volume. We're going to do the volume. Actually, we'll put it in a function. Like, I mean, it's a really short program, but let's just practice putting this stuff in functions. So definition, vol sphere, and with the bar, and then let's do definition SA sphere, so surface area sphere. And then we'll make this a comment. This function calculates and returns the volume of a sphere. And then this makes it clear of a sphere. Okay, so this is going to be, so vol equals, let's do 4/3 So let's do, since we're not going to do any loops, we can just do pi equals 0.14. I mean, we can get real exact if we actually solve for pi here. If we had a function using the Leibniz approximation. I mean, we could do that. We could do that. Let's add that after. Let's add that after. Okay, so 4/3 times pi times r cubed. So now it's already going to know how to do this, but just for readability, we can kind of do that. So then we're going to return well, and then pi. We don't really want to repeat that. So let's call this pi, and then so that way we're not repeating code. So then let's out here will be pi equals 1.4. And then when we call these, we'll call them in our statement. We'll just have these print statements like the volume of a sphere with radius, comma, and we'll call this radius is, and then we'll call it here. We'll just do vol sphere radius, right? And then print. We can do it all in one shot. Right, the surface area of a sphere with radius, comma radius is a sphere radius. So that's 1, 2, 1, 2. Pretty sure that's good. And then volume. Oh, we're gonna pass into so print. That's gonna be please enter the radius. So that's gonna be actually let's do radius equals float, right? And then input. I think this is good for you. Not bad. Let's do the surface area. So let's do so this is going to be radius, comma. We don't want to do the same thing. Let's just put pi, like lowercase pi. I might get screwed for some of this stuff because I'm not like this super genius at this stuff. I'm still kind of learning along with you, but I'm hoping that this process will give, sort of insight to, when I stumble and mess up, to just, where to look, where to be resourceful, how to think about things, how to remember things, how to memorize things. So, all right, let's do this one now. So SA sphere, this is going to be, so SA equals equals pi times r squared. Now, because we're doing this, exponentiation, and we don't need math.pi, or excuse me, we don't need the math module. I don't believe. I think that's totally sufficient. I think if you use the power function, then we would need the math module. But I think we're fine with this one. So okay, so let's try it out. Okay. Here we go. Oh, nope. We missed something here. We missed return. Return is very important in functions. And radius is going to be a float. So just in case they put a float, they might, put an integer, but you never know. All right, so let's save it. So that saved it in our atom. All right, so let's do 4.5. All right, 81.51, 54.34. How can we tell? Well, we'll multiply it through. Let's try it. So let's try it. 4.5. No. Let's just do everything blocked off. Just so we can see it also. Now here, I think you got to use the caret, because I think in Google you use the caret, and then in programming you use the two stars. You use POW. I think that should work. Actually, the R doesn't work because that's not a number, a calculable number. 31.51. Let's see. Oh, that's right there. Boom. Let's try the other one. That seems pretty good to me if we got that one, but let's try the second one. It's going to be, let's just separate these so we can see them. 14 pi. This is going to be 4.5 caret 2 into Google 254.34. There it is. Nice. If we really want to get down to the brass tacks, we can pull this code from Leibniz, which will be exact. And let's see how this looks. So we're going to do my pi 10,000. Right. I'm going to do my pi. So we're going to run my pi. So we're going to erase this. Let's run it here. It's going to be my pi. We're going to run it inside these functions, because that function was defined first. So we're okay. So we're going to actually call these functions inside of the other functions. Then we won't need pi anymore. It makes it a little bit simpler to read. And also, you can also mention this too. You can say this function uses the Leibniz. I'm totally butchering this guy's name. Formula calculate pi. Okay, let's try it. Check it out. Just literally use code from another program that was. And then let's see how it looks. So let's. And that's what I hear a lot of with guys that are talking about the industry and just programming and just a lot of folks talk about it. Like use different code bases and you know um, so let's check this out. So let's run. See how it looks. Oh, so there's a little mistake. There's a little mistake. I don't know what the mistake is. Something like EOF. Oh, this thing right here. Oh, it probably needs a parenthesis somewhere. Yeah, it needs another parenthesis. Yeah, because we originally erased it because of getting rid of the word pi. So we're gonna run it. Oh, we're gonna run it. Let's do the same thing. Let's see if we can get more accurate. Ooh, there it is. 31.69. What we could do here is we can go to here and let's print my pi. Actually, we're gonna print so we're gonna print my pi with a 10,000 as the argument. And let's see how exact it is. Let's run this again. Okay, now let's see how exact we are. I mean, this program basically uses the Leibniz formula where you're at is 1 plus 1/3 minus 1/5 plus it just goes, it's online. And the denominators alternate from like 1, 3, 5, 7, 9, and then the signs alternate from plus, minus, plus, minus, plus, and then it's plus 1/3, minus 1/5, plus 1/7, minus 1/9. Or I think it's 1 minus 1/3 plus 1/5 minus 1/7 plus 1/9 all the way on. So we did this 10,000 times, which would probably get us a pretty accurate entry. However, let's look at pi. I don't know if it's too exact. It should be 3.14159265359. So the tenths, hundredths, thousandths, 10,000ths. Is that because of this number 10,000 here? I'm wondering. I don't know. Because it's like really exact on everything except for. Yeah, it literally is. Like, look at that. 3.14155 49265359. That's interesting. 10 thousandths. I did this wrong. And then this comes 1 equals 5 plus. Because this alternates the signs. Times -1 times 1 times -1 times 1. I think it's this number right here, the y times 4, because the answer is going to be pi over 4, so you're going to multiply pi times 4. It's interesting, but I'm sure, you know, if someone wants to put in the comments, you know, but yeah, I mean, it's still pretty accurate, but just that one digit seems a little bit off. So, but anyways, to go back to the original problem, we're looking for volume and surface area of a sphere. And here they are. We're obviously, you know, we would test this like 5, 10, 12 times or whatnot. I think it's decent in terms of comments. And yeah, that was number 1. Thank you very much.